Hi everyone. So today I am going to give you a video tutorial all about the applications of first order differential equation, particularly that is using Torricelli's law. The applications involving the Torricelli's law, and that means like the situation that we have a tank and we are looking for the equation of time t to be emptied, or like at a certain time how much is the height of that water, like that. So to solve for that equations, to solve for that problem, for that application, we might needing this process. I'm having a problem with my ball pen. Okay, with the process. First we have to find the volume. We have to determine the volume of the tank, and that volume depends on the shape of the tank. For example, it is a right circular cylinder like that example I showed to you, a cylinder, hemispherical, etc. Any shape of the tank. So that means it is your task to know the equation of the volume. For example, what is the formula of the volume of a right circular cylinder, or a hemispherical, or a spherical tank, like that? So there are many complicated or there are many shapes of a tank. So it is your task to find or to determine what is the formula of that volume. And of course, we're not just dealing with a constant volumes like this, but we're dealing an integration, or at a certain of time of the height, let us say in y, that is we have a coordinate x and y. At a certain time, our y is like something right here, over here, and or maybe over here. So that means we are dealing with a dv, not just a v, but dv, right? So we have to know what is our dv formula. The next is, by the help of Torricelli's law, it states that Torricelli, let me check the okay. Oh no, this is I. Torricelli's law state that the velocity of the liquid gaseous in order to flow from the orifice, or this from the water to flow, is the velocity is just equal to the square root of 2gh. Where do I get this? From the Torricelli's law. And how he formulated it? Of course, that is just the kinetic energy 1/2 mv squared is equal to the potential energy, which is mgh. Cancel this thing and find for v. Luckily we got 2gh. So that's it. This is the kinetic energy equals to the potential energy of the liquid. So from this idea, that means when we have v times dt at a certain of time, that means it will result into the length of the y, right? Length of the height, or let us say y, because it is an instantaneous height of the strip or of the water. So when we have this, a length, for us to give as a volume like dv, another dv volume, we have to know the area times length. and this area is the area of the hole. In this example, suppose our area here is that our radius, let us say the radius right here is just radius r from that hole, right? Okay, so that means, for example, maybe this would be pi r squared times the length, which is this one, and no, this one v dt is the length. That means we'll not use h because this is a constant, but we rather use y because we are depending on at a certain time of the y. So we use 2gy times dt. So this is already a volume, but take note that it is negative. Why? Because the water, if this is a full of water, the water will flow out of the tank. That means it is negative. Okay? Okay. So since we have two equations of volume, this one and this one, we can actually equate this two, right? So that means this is already a constant formula. We have this formula. Luckily we have this already a formula. And then next the problem is that we determine this formula. Okay? Okay. So for example, in this problem, this can be found on page 55. Of course, the same book we are using, Advanced Engineering Mathematics by Ray Wiley, and it is number 13. Okay, number 13. Okay, so the problem states, or the problem we have is that, okay, if the tank has the shape of a right circular cylinder of radius r and a height h, and if in addition to a hole of radius r in the bottom of the tank there is also a hole of radius r in the side of at a height of h/2 above the base, which the water drains under the influence of gravity. Find the depth of the water in the tank at any time t and determine how long it will take the tank to drain completely. Okay, so we will solve that question. So as you can notice to this illustration, we have two holes. Let us say this is the hole number 2 and this is the hole number 1. This is the hole number 1. Okay, and they both have the same area, pi r squared. Okay, they both have the same area, and then this hole located at h/2 from the base. This is the base over here. So, and then okay, so the first thing to do is that okay, wait, I realized that when there is two holes, that means we have two conditions. Let us see, for example, okay, so we have a water at this certain y, h/2. That means from the height h from here at the top to this at the center of the tank, that means there are two holes that may be the reasons for the water to be to fall out. That means, okay, that means at time 0 the water will flow by this, okay, by these holes right here. The water will fall. These two holes will be the reasons to drain the water completely. So from at the top, that means there are two holes for it to, there are two holes. That means two holes are active for this water to drain. So like this. So at this time, let us say at time where y is equal to h over 2, that means we have two conditions. So first condition is that when our y is from height h, from this height over here at the top, and then h over 2, that means we are considering this 2 right here, okay? And the second condition is when our y is from here, h over 2, up to when it is empty, that means 0, okay, from here, okay. So that means we have two conditions, okay. So for the first condition, that means when our y is between the height h and height h over 2. So we equate these two equations of dv. That means we have pi x squared dy is equal to negative pi r squared square root of 2gy dt. This will cancel out, and then we transpose negative to the other side. That makes a negative x squared dy is equal to r squared 2gy dt. So take note, from this drawing we can say that our x squared is just equal to r squared over h over 2 r squared, since r squared, and then over h over 2 times y minus square root of y squared minus yh over 2 d. Okay, that's one over, okay, like this is our x squared. So by substituting the value, okay, taking the value negative r squared over h over 2 y minus square root of y squared minus yh over 2 dy is equal to r squared square root of 2gy dt. Okay, so as you can observe, there is in this term there is still y variable, and we want to separate y variables, the y from t, if ever there is t, but from here there is no t variable. So we have to separate y, we have to put y into this term. And to make our calculation easier, this constant will also transfer this constant into this one. So everything will be multiplied to y to the negative 1/2 times, okay, h over 2 over r squared. Okay, So this thing will cancel out. So we have negative times this one becomes negative, and times this one becomes positive. So we will rearrange the term so it becomes like this: y squared minus yh over 2, and we have this. Actually, we have that negative 1/2 to the negative 1/2, and then minus y. Okay, dy is equal to, this is equal to r squared square root of 2g over h over 2 r squared dt. Okay, so we want to get a y to the power of 1/2 for this thing to be cancelled out, or we will multiply this into this thing over here, or over this thing. So that means we will have this equation. I hope you can get it. So that this is becomes y, and then h over 2 minus y to the 1/2. Okay, times dy, and we have h r squared square root of 2g over 2r squared dt. And now we will integrate this at the both sides. Okay, so integration of this term is just, this is y to the negative y minus h over 2 to the power of 1/2. So that means we just add 1. I hope you can get it. So that would make it 1 minus h over 2 to the 3/2, since 1/2 plus 1 3/2, over the reciprocal, it is 2/3, minus the same thing, we have plus 1 here, have y to the 3/2, and then this is 2/3, and then this is all constant, and you have just t, so it just hr squared square root of 2g over 2r squared, capital R squared, times t plus c. Okay, since this has the factor, or this have a factor of 2/3, it means we have to multiply this by 3/2. Everything will be multiplied by 3/2. But take note that this 3/2 times constant is still be constant, so we will not make it 3/2 c, but just c. Okay, this would make it 1 minus h over 2 to the 3/2 minus y to the 3/2 is equal to 3 hr squared square root of 2g over 4 capital R squared times t plus c. Now we will get the value for c. That means in this condition, so that means we assume that at time t is equal to 0, that means the starting or initial time, our y start with h. That means it is full. The water is from the height h. Okay, so that means we substitute everything with these values, so that becomes h minus h over 2 3/2 minus h to the 3/2 is equal to, this is 0 plus c. So we have h to the half, h over 2 to the 3/2 minus h to the 3/2 is equal to c. And then we substitute c into this. We have, okay, back to the equation. We have y minus h over 2 3/2 minus y to the 3/2 is equal to 3hr squared square root of 2g over 2 capital R squared t plus h over 2 3 halves minus h over h to the 3 halves. Okay, but okay, so we'll have to make this what if we have to transpose this to this thing? Though this is a correct answer already, but we want it a more beautiful answer. That means we have a function at this left side, we have functions of y, everything with y and h, and over here is just a function of t. So we transfer over here the constant, this constants, which is equal to c. What happens is that this becomes negative, means y minus h over 2 to the 3 halves minus h over 2 to the 3 halves becomes minus, and minus y to the 3 halves, and this becomes positive, but we have negative here, so it still be negative, because negative times negative is positive. So h to the 3 halves is equal to 3hr squared square root of 2g over 2r squared t. So that means at a certain time t, then time t, this is the function, or this is the depth of the water. Okay, so this is the depth of the water. Okay, now the other question is that when the time, okay, so since we have this condition, that means at a time h, at a certain time, that means at a certain time, what is the time? That means, how I can explain this? Okay, that means we have the function of y that is from here, that means the depth of the water at certain time t. We don't know the time, but a certain time t, this is the formula, or this is the equation of the depth of the water. And now what we need is the time at what is the time when the water is at this level, h over 2. That means, okay, at this level, and we will give that a name like t at the time when y is equal to h over 2. That means t to the subscript of h over 2. Okay, so what is this time? But the condition to that is when y is equal to h over 2. So you just substitute to the values we got here. So that means our y is h over 2 minus h over 2 to the 3 halves minus h over 2 to the 3 halves minus h over 2 to the 3 halves minus h to the 3 halves is equal to 3 hr squared square root of 2g over 2r squared, and this is t when h is equal to 2. Subscript t is equal to 2. So that means this becomes to 0, negative h over 2 3 halves minus h over 2 to the 3 halves plus h to the 3 halves is equal to the 3hr squared square root of 2g. Excuses. Actually this is 4. This is 4. This is 4. So we will use this 4 for r squared t at h over 2. Okay, so this is negative 2 times h over 2 3/2 plus h over h to the 3/2 equal to this thing, and then this is negative 1 3/2 minus 1, that is h 3/2 over, that is over h to the 1/2. I know that is 2 to the 1/2 plus h to the 3/2. Okay, and we have this 3hr squared square root of 2g over 4r squared. Okay, so this is t times h over 2. This is square root of 2 negative h to the 3/2 plus square root of 2 h to the 3/2 is equal to 3hr squared square root of 2g over 4r squared t times t and times t. Okay, multiply this by square root of 2 for this thing to be cancelled out. So we have h to the 3/2 square root of 2 minus 1 is equal to, this would become 2 divided by 4, that is 1/2. So we have 3hr squared square root of g over 2r squared t h over 2. So we only need this one, so we have to multiply everything by this equation, 2r squared over 3hr squared square root of g. Okay, so that means h to the 3/2 divided by h, that means you have h to the, or square root of h times square root of 2 minus 1 2r squared 2r squared over 3h r squared square root of g is equal to t h over 2. Okay, means we have this, or writing this, we have 2r squared square root of 2 minus 1 square root of h over 3h r squared square root of g is equal to t h over 2. So this is our t of h over 2. So that means when y is equal to h over 2, this is the value of time, this is our time. Okay, so at the second condition we have this we have this second condition when our water is between h over 2 and 0. So only one hole is active, and we got this formula before. So while we are solving this condition 1, we get this formula: x squared dy is equal to negative r squared square root of 2gy dt. So as you can see, our x here is just r, because the water level, or in terms of x, is just moving at these edges right here. That means it is constant, it's not instantaneous. Okay, so that means our x just r, so that means we have r squared dy and negative, so we have this equation, our x just to r, equal to r. So since we have square root of y over here, so we have to transfer it here, and this constant r, capital R squared, transfer it here, so we need this factor, negative y to the negative 1/2 over r squared. So definitely we could have this formulation, y to the negative 1/2 dy is equal to negative r squared square root of 2g dt over capital R squared, and then we will integrate both sides. So this would become y to the 1/2, this is 2, is equal to negative r squared square root of 2g over r squared. But think of it that our boundaries, or our upper bound in terms of time, is from the time when this is at the top and when this is h over 2. Okay, so that means we could have this t minus t h over 2, or this time is at a certain time, that means an unknown time, but you can solve the equation, you can not particularly at the top or at the bottom, but maybe at the top or between, from here, from the top to the bottom. Okay, and then at the time minus th over 2, because of course we have this equation already, th over 2, so we need this, our upper bound and our lower bound. But if as you can remember, our value for time t h over 2 is just equal to, okay, so this would be 2y, or square root of y is equal to negative r squared, or this is small r squared, square root of 2g over r squared, and this is t minus, we have this 2r squared square root of 2 minus 1 square root of h over 3r squared square root of g. So this is our equation when our y is between here. And of course this have plus c and plus c. So okay, to find c, our y must be equal to so when y is equal to h over 2 and time minus t h over 2 is equal to 0, that means our t is equal to the time when the water is at the half of the height. Okay, so that means this become like this, so this becomes 0. So our our c is equal to 2 square root of h over 2, or this would be 1 minus 1/2, that is square root of 2h, square root of 2h. Okay, so that's our c. So we have this final answer for that is equal to 2 square root of y if r squared square root of 2g over capital R squared t minus 2r squared, square root of 2 minus 1, square root of h over 3r squared, square root of g plus 2h. Now, to find t of 0, that means the time that when there is no water left in the cylinder, that means it is empty, we just let everything by we let y equal to 0, and then we get t of 0. And if you have to let this equation into we let or substitute the value for y is equal to 0 over here, we get t of 0 is equal to r squared over small r squared times square root of h over g times 2 square root of 2 plus 1 over 3. Okay, so that's it. You have this equation, we just let y is equal to 0, and then you will get this t of naught, which is t of 0. So that's all. Okay, thank you for listening, and good luck to your studies. Happy living. Bye bye.